designing a high frequency trading platform. So this video is more of a thought experiment. Target audience would be developers, also trade support folks, also maybe technical sales, some business analysts and things like that. I am not the person that you would want to build a high frequency trading platform. That is not my area of expertise. I could certainly contribute to the discussion in terms of the design and architecture. And I'm currently doing some research on high frequency trading from the context of building my mock trading platform, Mercati. Mercati starts as a very basic stick figure design, very crude implementation, and over time I'm going to make it more and more complex, more and more advanced. And then the long-term goal, I have a performance target of 1,000 transactions per second. So I guess let's step outside of that particular project and focus on this video, which is how I would, as a person who does not have expertise in doing something like this, but I do have a lot of knowledge about electronic trading platforms, 25 plus years of experience. So using that experience and what I've learned in my study of high frequency trading systems and trading systems in general, in terms of the architecture, this will be my approach, right? So first of all, I'd want to start with what are the goals? What's the performance metrics that I'm trying to achieve in terms of what I want this system to do? What kind of numbers, transactions per second, whatever it is. What is the ultimate goal in terms of what the system can do? I would then want to focus on what is possible in terms of what is known to be possible. So I want to look at, what we have in terms of systems that are existing. What are they capable of doing? Look at the delta between what they can do and what we're looking to do. So I want to see where we exist on the spectrum. Are we looking to, be sort of on the bleeding edge to the point that we want to exceed what other firms are doing, what is known to be possible? So we want to get into the experimental realm. Or do we want to build something that is capable on the same level as other systems? Now, once we have that clarified, what is possible, I'd want to also be very clear on what the limitations are. So, what are the bottlenecks? What are the challenges in terms of you're building a trading platform, achieving, extreme performance? What are the difficulties? What parts of the system are slowing things down? Whether it be the hardware, from the server perspective to the networking architecture, the software design. Obviously, the way you write your code has a big impact on the efficiency of that system. So I want to look at all the areas. What are the problem areas? What are the challenging areas? What are the bottlenecks? Because if I'm going to build a system that's going to be really fast and powerful and competitive, I'm going to want to be a master at everything that would potentially get in the way of achieving that goal. And that would be all the potential bottlenecks, right? That being said, I would want to. Hey, good to see you, man. Yeah, I'm working on I got a lot of stuff that I'm working on right now in terms of videos. Trust me, the deep dive is really killing me though, because I'm doing a trading system deep dive, and it is nothing like you've ever seen before, nothing like I've ever done before. So it's a pretty big undertaking. It's over an hour long, so I mean it's going into deep detail. So stay tuned for that. But in terms of so once we have what the goals are, what we're trying to achieve, and we know where the challenges are going to be potentially, then And I think this is an interesting thing discussion to have because for those of you guys that have not really explored the high frequency space, and even just in general, maybe you're a trade support guy and you kind of more surface level. You're looking at the fixed logs and you know doing troubleshooting and all that kind of stuff, but as you're not a developer, your knowledge of what's under the hood is very limited. If you're not a desktop support guy, you're not going in the data center and things like that. You're not touching anything. So your knowledge of these systems that you're supporting might be limited. So in having this discussion, I'm going to open your eyes to some things that you may not be aware of. And I want to let you know how extreme things can actually be to achieve what we do. So, based on how extreme our goals are, well, let me start with the first framework. So, contrary to the way you might normally look at something like this, I mean, the stuff that we're doing in trading is, I mean, the performance levels are so extreme. I mean, we go from people talk about seconds. We don't care about seconds. We do not care about seconds, right? We care about milliseconds. We care about microseconds. We care about nanoseconds. We are doing so many operations in a fraction of a second. I think, a thousand transactions per second might sound impressive, doing 1,000 operations per second. Now, what are we talking about? We're talking about you have a parent order. The viewer just mentioned algorithms. You have a parent order that you send to an algorithm. An algorithm is going to slice it up into many child orders. So you want a million shares of something, and I'm going to break that million share intent. I have an intent to buy a million shares. I don't want to actually throw out a million share buy order. I'm going to move the market. We want to be very strategic. So we're going to break it up, slice it up. You have the algorithm that does that. If the algorithm generates in the blink of an eye, fraction of a blink of an eye, 1,000 child orders, boom, 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 boom. Every single one of those child orders, we have to do calculations on every single one. There's risk checks that need to be done. Right, we gotta validate these orders. We gotta look at. We gotta process in terms of your buying power constraints, how this would affect your exposure levels. There's so much calculations that need to be done. And if you're generating 1,000 orders, that's 1,000 orders that you need to do calculations on. That is insane to handle that in a fraction of a second. But 1,000 transactions per second is not something that is, well, it's you got it's the context, right? That could be impressive, but when we're talking about the extremes in terms of what is possible and what has been possible and what is being done at the higher level, I mean, we get into the thousands per second. Some of the numbers I'm hearing, I'm reluctant to even repeat. None of this is like proprietary stuff. You do the research, the papers are out there, you can see it yourself. But some of these numbers, it's just mind-boggling even to me. I mean, I'm hearing things getting to the extreme level of, I mean, certainly 5,000 transactions per second, 10,000 transactions per second. And then when you start talking about 100,000 transactions per second, then it's like, whoa, what, how are you even pulling it off? Can you imagine 100,000 transactions in 1 second? I mean, that's just mind boggling. But in order for us to get anywhere to that extreme level in terms of our design, the idea that many of you may have of just like throw a fast computer at it, you got to move beyond that. It's not just, because I know most people, most normal people, even, you've been trade support, but you haven't gotten to that level. You're just thinking, fast CPU and lots of RAM and, what's the fastest server? Get the fastest server, and again, it's all context depending on what your goals are in terms of what the system should be able to do. That could work. You have you design your software, in a efficient way, and your server might meet your demands. But if you're trying to get extreme, if you're trying to do some 10,000, hundreds of thousands per second, that's not gonna fly. So let me introduce you to the world of high frequency trading technology. Mindset. This is not like a specific, this is how you must do it, but this is the thought process, right? So we already started with what are we trying to achieve performance wise? What are the bottlenecks? What are the challenges? We need to be able to master all those areas that are going to be a challenge potentially, right? These are the things that will stop us from our goal. So we need to know every trick in the book to overcome those limitations. Then we need to start with a re-evaluation of how we do things from a fundamental level. I mean, super granular. I mean, you can go to an extreme, depending on what you're trying to do, but you go to the extreme of, we're going to custom design every component of a computer. You could theoretically optimize specifically for the specific task of trading. I think if you were to do every single component, you are gone way beyond excessive. So the thing is, what is that sweet spot, the threshold between you pretty much designing an entire new computer just for trading, right? That is like you have gone to another galaxy if you're doing that. But thinking about that, just the idea of constructing an entire custom computer from the ground up, that's where your mind has to go when you're trying to achieve some extreme performance results, right? But we stop way before getting to the level of a whole new computer. But that's just I'm just getting your feet wet, right? Getting your feet wet on that. So what we want to think about is, so if I'm designing something, right? And again, as someone who, this is not my area of expertise, right? So just bear that in mind. The first thing I want to start with is I want to start with a Linux distribution that I can completely customize, purpose built. So I'm building, so let's say, there's a lot of components to trading system, right? So let's just say I'm building a trade server, right? I want to install on that trade server a Linux distribution that is very minimal. I don't want anything on that server as far as Linux that is not necessary. Every single piece of that operating system that I put on the server has to be something that is absolutely necessary. Security, networking, processing, whatever it is. If it's not needed, get rid of it. So that's the first step. I would want to build a custom OS implementation that is purely focused on trading and nothing else. So we have a lean, mean operating system that is optimized for that single task of trading. Now, we don't want to get too excessive or extreme. Like I said, I mentioned security, right? There's other things that the machine needs to be able to do other than just trading. But again, the key thing is not that it's only for trading. It's only things that we need, right? Everything that this machine needs to do from a networking standpoint, from a security standpoint, from a processing standpoint, whatever it is, that's the only thing I want on there. Everything else, get rid of it, right? That's number one. Number two, the type of hardware that I'm going to use. So what machine am I installing this on? I want a machine that I can tune to get optimum performance. So I'm looking at things like NUMA, so non-uniform memory access. So I want to use NUMA aware hardware I want my development team to use NUMA concepts. We're talking about proximity concepts where you're so like we mentioned, we talked about the pre-trade, right? That's a big load right there. I'm generating a ton of orders really quickly, and I need to do calculations on every single order, right? So my ability to achieve a high amount of transactions per second means I need to optimize all of this processing, right? I need to maximize everything. So, for example, the location of the data that we need to do the processing on, I'm concerned about the distance, the proximity to the core that is doing the processing. So, the part of the processor that is going to do the math, you have to consider this is how extreme it gets. You have to consider the time that it will take for the data that is within the memory to be accessed by the processor. That takes time. Normally, normal people in normal situations, we don't really care about stuff like that. I mean, maybe in a gaming framework, I could see gaming, you might be thinking on that level, but normally, I mean, the time that it takes to for data to go between the processor and RAM is so small that that's not something we normally care about. But if you're trying to do what we're talking about, then you want to do, and I forget the terminology, but basically with NUMA, you want to have your so the way that the data is going to be stored and processed, you set up sort of partnerships, for lack of a better term, where this core is going to do processing on this data, and the data is going to be stored really close to that core. So you're basically the path between the processor and the RAM is minimized, right? So these are the types of things that you're talking about if you're trying to do high frequency trading, right? So that is one of the many tactics, right? So that's a programming implementation. It's a hardware implementation. Obviously, the standard stuff applies. You want fast CPU. You want a lot of cores. You want a lot of RAM. You want fast SSD drives. Obviously, you want to have the maximum throughput. And beyond that, so we have a custom operating system. We're programming using the latest and greatest techniques in terms of optimizations, like NUMA, for example. And then beyond that, we are looking at, I guess we could jump to the networking hardware. So obviously, whatever we're doing, we're not just doing it locally, right? We need to have an order generated and have it transmitted to another location and then transmitted down to the exchange. All of this takes time, right? So I would want to look at in terms of the design. I'd want to obviously look at things like concepts like co-location. So co-location is where we locate the trading servers on the exchange. So a co-located server we have located on the actual exchange floor. On that server, you would install your execution management system. So instead of me doing all of these risk checks and everything locally within our data center, what I would want to do is I'd want to have the order sent as quickly as possible down to a server located on the exchange, right? We have, super fast market data coming in straight from the exchange. UDP protocols used, it's streamed really, really fast. So this server can make decisions in a blink of an eye, fraction of a blink of an eye, right? Generate all those orders, process them really fast using the NUMA concepts. And we're going to talk about GPU as well. That's an expansion of, how we can do a lot of transactions per second. So we're making decisions on the exchange floor. So once that server decides based on market, so the market data comes into the server, boom, blink of an eye, fraction, nanoseconds, the data's there. We see prices on all the instruments that we want to trade on, right? Instantly generate those orders, thousands of orders, right? Process every single order, do all your risk checks super fast, right? NUMA architecture. You'll have a lean, mean operating system on that machine. You're using concepts like pinning, so you actually dedicate. I think affinity is a term, but you actually dedicate a specific core to a specific application or instance. So you have exclusive access to a core. This is my core. Nobody can touch it, right? So again, maximize everything fast, 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 right? Generate all do the risk checks, right? And then in a fraction, of a second, send all those orders through a cross connection, right? So you have a direct connection from your server because you're in a shared data center with the Exchange servers, right? So you send those orders right over, boom, cross connect cable, boom, over to the Exchange, their infrastructure. So it will be, and I guess also I could reference that. Again, things are such an extreme level that we're concerned about the length of the cables. So the Exchange, to keep everything fair, they would, and I'm not a hardware guy, but the fundamental principles that I'm aware of is what they would probably do is something like they have their data center planning that, this is the area where we're going to have all of our servers for our clients and our servers, right? What is the longest distance from our servers to where the client servers will be? What's the length of that cable? Let's make every client's network cable, their cross connect cable from their servers to our network, the same length. So if your server is physically closer than another client whose server is really far, you're not going to get an advantage because you're going to have excess cable length. I don't know if they use other tactics as well to make the speeds the same, but this is a fundamental concept that they would use. They would have the cable length be the same. So you're closer, but the data packets that are going through that cable, they have the same distance to travel as the guy who is furthest away. So we have everything normalized. I don't know how they prove that, but I'm sure there's different mechanisms like you could do. You probably advertise your latency performance that you offer to clients, and if pings are enabled, the clients, I guess, theoretically can do pings, and you'll see like how long it take for your packets to go round trip. So you could verify that you're getting what you were promised. There's also other tools as well. You have Wireshark and other tools that you can use to analyze your latency, so you can know that you're getting what's advertised. But these are the kind of things that they're doing. So you and I just want you to understand, like, why do we even care about the server being located on the Exchange floor? Because you might think, okay, it takes time to do these risk checks on all these orders. Okay, but it's going to take time on the Exchange floor. It's going to take time in your data center. What's the difference? Let's just give a unit of time that's simple. Let's say it takes a second. It's much less than that, but let's say it takes a second, right? So it takes a second to do all these risk checks in my data center. In that data center, it takes us a second. So what's the advantage? The advantage is these child orders that are being generated based on market conditions, right? It's based on what's happening in the market, right? So you look at your market data. So this prices, right? Prices. What is the current price of this stock at this instant, right? Based on that price, I'm going to make a decision on, in the case of a limit order, what limit price I'm going to put on my order to get the best possible execution, right? So the time between my awareness of the price and my generation of an order based on that price, that's the point, right? If I'm making those decisions locally in my data center, right? First of all, there's a delay of the market data to get to that system that's in my local data center. It takes time for that price to get to my system in order for me to react to it in the first place. And again, when you're dealing in microseconds, when you're dealing in nanoseconds, these details matter. In a normal world, you think like, man, that stuff, look at how I can send files across the internet or whatever, and how quickly it go. Listen, man, when you're in microseconds, when you're in milliseconds, when you're in nanoseconds, these details matter, right? It is an eternity for the market data to travel from the exchange where the executions are occurring, right? To travel from that exchange to my data center and then to be available, on the whatever system that I'm using. That is too much time. So I have a delay. I'm already behind. The time that it takes for the quote to show up on my system, that is already, I'm behind. Then my system needs to do the processing and decision making and okay, these are the prices I want to do. By the time you are done doing that, right? And then you start traveling down to the exchange to get your executions. The prices could have moved. Now, you might rightly suggest the prices probably won't move that much in that fraction of time. But when you're dealing in, large orders, high frequency trading, you're competing with other high frequency traders, small slippage in the price that can happen between the time that you get this delayed price because it took time to get to you and the time that it's taking for you to send the order down to the exchange, that's a round trip delay right there. Upstream to you, orders downstream to the exchange. By the time that happens, in comparison to somebody who is co-located, you are behind, right? Because in the time it takes for you to do that, my orders are already filled. Think about that. My orders are already filled by the time, I think by the time you even are aware of the prices. By the time the prices make it up to you and you see what the price is on the instrument, by the time you see like, oh, the price is whatever, right? I've already generated my orders, sent them to the exchange, and executions came back, process, done. And there you are, slowpoke coming in with your limit prices based on something that happened in the past. Now we're talking about small amounts of time, but when you are dealing in high frequency trading and the volume, the size of these orders, the amount of transactions, this can add up over time to a big price difference in terms of, when you look at, how we are doing in terms of our P&L, our profits and losses. We can beat you out by a significant degree, right? When you're at this extreme level, that is how you have to look at things. So with the co-location, we have the servers there that is getting the prices as fast as possible via UDP. And I believe this would fall under the context of is this, I guess this would be considered, we're getting in the realm of edge processing. So it's all about proximity, everything. So within the server, proximity between the processor and the data, right? Within the exchange, proximity between our servers and the exchange servers. Everything is about getting as close as you can, limiting distance. Distance means time, and if it's all about time in the exchange world, the trading world. So those are things that I would want to look at. And as far as networking, the other thing I don't think we mentioned is something called kernel bypass. So again, you're such to an extreme level, right? Depending on what your goals are, of course, it's all relative to what you're trying to achieve. If you're trying to achieve, something at the top level in terms of what is possible, you use things like kernel bypass. So kernel bypass it's an interesting concept, right? So you have these data packets coming back to the server, right? It hits that NIC, right? You have your network interface card, and the data comes in, and it's polite. It's polite for you to stop by the kernel and say hi, and hey, I'm an execution. I'm coming to fill this order on Apple, whatever. How you doing? How's your day? Right? That kind of thing. That would be polite. That's the way we normally conduct things in the computing world. But this is a race, right? Trading, high frequency trading it's a race, right? We don't have time to small talk. We don't have time to chat and stop by and say hello. Kernel bypass. We send that data through the network cable, through the network interface card, and we don't even stop by the kernel to say hi, right? That data goes directly from the card to the application, right? Shaving off even more time from the process, right? So these are tactics and techniques that I definitely want to explore. Beyond that, obviously, how the application is designed, the software itself. We talked about NUMA techniques. Beyond that, every single thing that you do, we'd want to optimize. And I forgot, actually, there's another hardware thing I forgot to mention, FPGA. So, when you're getting at the really high levels, everything that I discussed might still not be enough. A CPU, and we didn't talk about GPU as well. So let's briefly talk about that before we get into FPGA. So the CPU, so you have a CPU with multiple cores, multi-threaded application, NUMA architecture, and you're going to reach a limit in terms of what that CPU. I mean, obviously you could theoretically get a processor with more cores, but if you're trying to get to the maximum level, you're going to get to the limitation of what that processor is capable of doing, what that system is capable of doing. So what we started doing is a lot of the pre-trade risk checks, a lot of what we need to do, the processing on these orders that are being generated, it's math, right? We're talking about mathematical operations. The CPU is perfectly capable of doing math. I remember when I was a kid, we had something called a math coprocessor. What was it? A 25 mega, 486 computer with a 25 megahertz processor with a DX250 math coprocessor. I forgot. This was so long ago. But basically, there was a processor specifically designed to do certain math calculations to offset or augment what the CPU is capable of doing. So in parallel with the CPU, you have this other processor that's doing math. So it's kind of helping out. That's in the 90s. But now we have something similar concept, but from the graphics world, we have a GPU, graphics processing unit. I think most people in trade support, might not even realize, and it depends on what kind of system you're supporting, right? But might not even realize the relevance of a GPU. Obviously, you probably think of a GPU from a graphics processing standpoint. However, again, with high frequency trading, its speed, its performance, you want to maximize everything. So you want to leverage every tool possible to maximize your performance. So you have this processor that's capable of doing mathematical operations. CUDA cores, NVIDIA CUDA cores. We have math tasks that we need to do very quickly in parallel, right? And we have this processor that's capable of doing math. How about we write our application such that we send some tasks to this GPU core to do some of the math, right? So now we have expanded the amount of transactions we can process in a second considerably, because we have the CPU with all those cores, we have the GPU with even more cores, and we can design an application that can utilize. I mean, obviously, this has to all work together in a way that's sort of makes sense, the most efficient way in terms of delegation of who's doing what and when and how you're communicating and everything. But that's another technique that we can utilize. We can utilize a GPU to help with some of the mathematical processing. However, when you've done all of this and it's not enough because you're so greedy, and I appreciate the feedback that you said your videos are really helpful for me to understand the trading infrastructure. And what did you say? And if we have multiple LPs, how can we achieve high frequency data points? So I'll address that later. So lost my train of thought there. I apologize. I think we were getting into FB. We're talking about GPU, and then lost my train of thought. So let's jump to the hardware. So if we've done, I think this is what I was saying. So if we've done all these things, and we still have not achieved our goal of how many transactions per second, TPS, how many transactions per second you're trying to achieve, then the next step of optimization and customization and just tuning is going to come from building custom, how do I describe this? So think about the CPU. So you have the CPU and GPU, but I think one potential issue with the CPU and GPU is that they were not purpose built for the task at which we are trying to achieve the maximum results or performance metrics, right? Just like in racing, I'm into motorcycles and cars. You know, if you're gonna build a race car, you want everything purpose built, the ultimate race car, right? You want an engine that's designed specifically for racing. You want racing tires with a racing compound. You want, brakes that are specifically, everything is built from the ground up, focused on the racetrack. Trading, no different. So at an extreme level, you can get to the point where the standard architecture of a CPU and a GPU, as impressive as it is, especially the way we're utilizing it, is not enough. And in that instance, we start introducing a technology where you actually build your own. I'm going to oversimplify it, but imagine an oversimplification. Imagine building your own custom CPU and GPU specifically designed for trading. That is essentially what we're talking about. We're talking about a board, sort of a board. Imagine sort of a mini. Think in terms of mini motherboard, mini bus, and it has a processor on it, and that processor is custom programmed specifically for trading tasks. So again, I think the best way to illustrate is we're talking about. Imagine the idea of me building a custom CPU, a custom GPU, or forget about those names, CPU, GPU. I mean, we're talking about chips, right? Processor chips. Imagine me building, and obviously with a CPU, you have, certain instructions that the chip has that you can tap into with your software. So now imagine if that chip that you're using for the processing tasks is a chip that was programmed and designed specifically for trading. So you could have this, and I'm not a hardware guy, but I believe this was something that would be installed on a trade server, and it would be capable of exceeding what is currently capable of using a CPU GPU setup. So that is where we go. Custom processors. Bypassing the kernel with the NIC card, proximity focused programming architecture in terms of the location of the data that's processed being closest to the core or processor that's doing the processing. DMA connections, right? You're having, instead of going through a hub and spoke network, you have a direct connection to the exchange. right? So you're getting down as quickly as possible. Co-location, edge computing, I mean, all of this stuff. These are the types of things that it would take to build the ultimate, high frequency trading system. Now, obviously, and we're not going to get into this, but obviously, with the new thing now is obviously everything is getting into machine learning. So that can play a part in it as well. There's certain parts of the process that can be optimized using machine learning as well. You can get into load balancing. There's so much, and that's why I'm doing a 1 hour plus long deep dive into these things. So that's all I wanted to cover. These are sort of things that I'm focused on right now. As far as with the mock trading platform design, obviously much simpler thing there. The plan is to start with what I have already, which is a very basic, sort of stick figure design. Then implement some kind of multi-threading, but I'm using Python, so I'm limited by the global interpreter lock limitation. So basically, it's kind of like Python has like a fake multi-threading. It's not really multi-threading. You're not able to run concurrently. These things like you would in true multi-threading. However, I'm going to see if I can bypass that by using a multi-instance design. So basically, instead of just one Python program, I would create as many Python programs as cores that I want to tap into. So one Python program spawns multiple Python programs, and then each of these instances are going to be able to run a thread concurrently. Problem I'm going to run into probably is the interaction between all of this, the coordination of all of this. I mean, it's if you don't really care what you're doing, if you're just trying to hit numbers, then I guess. But you know, the core instance, the Python instance that this coordinate everything needs to be able to communicate and keep track of what's happening with each instance, and therein lies potential delays and latency. But we're gonna see. I'm gonna push it as far as I can and not spend too much time on that because Python is really not the language for this. Then I'm gonna graduate to a hybrid model where I'm going to offload some of the bottlenecks to C++ most likely. So, for example, the OMS server component, the EMS server component that's handling the generation of all these child orders, that can be built in C++. I can stick to Python for the GUI, order entry. So you have order entry, you generate your parent order, all that stuff Python can handle easily. And also I might be moving to I'm not sure, but I have the monitoring console that's monitoring everything that can stay in Python. But once you transmit the order to the server that's going to do the pre-trade and everything, that's going to have to move to C++. So that'll be a C++ component. So you have Python program sending something to C++, and now you're in binary world. You're in a compiled language. You're able to process much faster. We can hit higher numbers. I think that's going to be where we can start playing with the GPU. I don't know that we can do that in Python. I doubt that. So, talking to the GPU, that will start probably in C++. All that NUMA stuff, I don't think I'm going to be able to touch any of that because I would need NUMA compliant hardware to do that. But we can at least we can maximize our CPU cores and maximize our GPU cores. And then final phase, we move to the cloud. I already am set up with AWS. The goal would be to utilize probably starting with EC2. So AWS EC2 M5.8 X large, I think, is the instance, which I think comes with 32 virtual CPU It's 32 virtual CPUs and maybe 128 gigabytes of RAM or something like that. So I'm going to push that as far as I can. And depending on what happens with that, we might consider, upgrading to the higher performance cloud instances that AWS has. I forget the name of it, but they have some higher cores, 128 cores or whatever ridiculous numbers. And I might cheat a little bit because I don't currently have the capability to build something that's going to be super efficient at all. The whatever I build is going to be probably not probably it's going to be embarrassing to someone that has the expertise in designing these systems from a programming standpoint. So I'm going to probably offset that by using excessive resources, right? So, whatever amount of cores I'm gonna, the way to design this properly is I would want to design an application that is so efficient that I'm not so reliant on hardware, excessive hardware, right? I will use as much hardware as necessary, right? But the idea is super, super efficient. So ideally, if I could build something that can hit the numbers, 50,000 transactions per second with only 20 cores, that would be great. That would be preferable to me designing something that does the same thing that requires 100 cores. Everything has a cost, right? If I'm making a system that is going to make us more money based on how well it performs, but it's going to cost us more in cloud infrastructure or hardware, whatever it is, that's going to offset. Like, what's the net result of the product, right? How much money is it going to cost us to design, build, support, and utilize this system? And how much money is that system going to be able to generate? What is the net effect? So, simply slapping a bunch of, hardware and cores at something, I mean, sure, but at some point in time, it's going to be diminishing returns where you're spending additional money, but it's not able to offset the delta between what you're spending and what you're making is just not very attractive. So you've got to hit that sweet spot. Utilize the power of these systems and technology, but only as much as you need to. So you want to balance it out. It's a lean, mean trading application. It's lean, mean trading applications. Lean, mean operating system, a custom Linux, custom Unix, and your hardware is lean, everything is lean, the way you do it, you're co-located, every strategy to sort of maximize performance. But gotta have that cost balance. How much am I spending versus how much am I making? That is it that I wanted to talk about. Hopefully this has been an interesting journey and helped some of you guys. Again, what I've talked about here is not, this is what you should do. This is what you have to do. This is not me talking as an expert in building these types of systems. I am just sharing what I've learned, what I'm aware of, and it would really be for you to, if it is of interest to you, to learn more about these things, right? I've opened your eyes perhaps to different concepts and technology that you may not have been aware of. And now is the time for you to go dig in if you want to learn more, right? So all the concepts I mentioned in this, kernel bypass, NUMA, edge computing, co-location, what else did we talk about? I keep thinking I'm mixing it up. FPGA cards, I think it's called. Custom operating systems, utilizing the GPU and even the time frames, microseconds, milliseconds, nanoseconds. All of these things are things for you to look into and learn and understand to a higher degree, depending on what you're looking to do. Maybe you want to actually be the guy that's going to actually build this. I'm just having a thought experiment. Maybe you want to actually do it. Well, those are the areas of things that you want to focus on. And I didn't cover everything. There's more concepts and techniques that you would want to understand. But if you research the things that I've told you about, by you researching those things, you're going to run into other concepts. And, it's kind of like a rabbit hole, right? You learn about those other things, and then that leads to another and another and another. And if you keep digging into it, then you'll get all the knowledge that you need. But I think I've mentioned all of the core fundamentals, most of them anyway. I'm not perfect. I might have missed something, but I think I've mentioned most of the core fundamentals that you want to be aware of. So anyway, on that note, this is Carlyle Speaks Wall Street, and until next time. And click on the like, guys. Michael Lansor says, thanks for your insight into such a complex design. Good information reminds me how far I have to go. If you're still here, when you say how far you have to go, where are you trying to get to? And if you're here and you can respond to that, otherwise I will end. You can also respond on the replay. Michael Lancer. I don't know why the chat keeps fading away. Fade away. Click on the like button, guys. I created this channel, I think 2006, with the idea of helping you guys, and I've helped so many people at this point, millions. Oh, learning C++. Oh, that's interesting. Yeah, because that looks like what I'm about to do. Because I need to get into compiled to be able to get these kind of numbers I'm looking to do. Python is just not it. It's a great language. It's powerful. I love the fact that it's very relevant for artificial intelligence and machine learning, because that's something I'm already in that Python world, and it's something I can continue using in that realm. However, in terms of high frequency trading and just trading in general, Python is not it. Anyway, thanks for joining, and until next time, and good luck to you, Michael, with your C++ journey. Share anything that you learn, and I'll share anything that I learn. I don't know how far I'm going to go with the C++. I just need it for the specific thing that I'm trying to do. I will definitely share that with you guys as well. So stay tuned. Until next time. And I'm closing it out with the middle finger. Wow. Unintentional.